Till now, we discussed about the what is HDFS, what is MapReduce, and what is Hive. So HDFS we are using for the storing the large amount of data, and we will store the data in distributed manner. And MapReduce is for the programming language for processing the large amount of data. So it will we can process the data in parallelly, and will provide the parallel computing or parallel processing through MapReduce. So then we discussed about the Hive. So Hive is a data variation tool we will use for the analyzing the data. So SQL kind of layer for the Hadoop. So we can analyze the HDFS data by using the SQL queries. So why we are moving the MapReduce to Hive or Pig means, so main intention to using the Hive and Pig are Hive and Pig, both tools are the will top on the MapReduce. So internally, so if you write the either Hive query or Pig script, internally it will convert as a MapReduce job. So generally, if you want to write the MapReduce program, we need Java program. We need knowledge in Java program or any other programming language. We need knowledge on that one. So and we need to write the lot of code for the mapper, reducer, and driver. So so I think most of the data variation people or retail people are most of the people are not data variation kind of people are not don't have the knowledge about the Java. So they have knowledge about the SQL only. For that one of the reason for going to Hive. So coming to Pig, we already having Hive. So why we have the Pig? So Pig is Hive and Pig both are the for analyzing the data. So anyone instead of Hive, in Hive we will have the SQL kind of layer. So in Pig we will have the we can write the kind of scripting kind of thing will be there. Simply we will have the different keywords for the each operation, for loading data, for filtering, for grouping. So simply if you want to analyze any data, we will write the whatever the operations we need, we will write the each 4 or 5 lines, and simply will submit the submit to the Hadoop. Then internally it will convert as a MapReduce job. So by using Pig, we can easily analyze the data. Simply we'll have the input, whatever the steps we need to analyze the data, we will specify, and final output will store into HDFS. So compared to MapReduce, so if you take the word count program, for word count program we need to write a lot of lines. So in Pig we can simply by using 4 or 5 lines, simply we can achieve that word count program, we can write it. So by using Pig we can reduce the lot of MapReduce code. So we can write the script, and we can easily execute the we can easily analyze the data. So coming to Pig, we will call it is we will also call it as a data flow language. So how we can analyze the data, we will specify that one. So then automatically if we submit the Pig script or Pig commands, so automatically we can analyze the data. So one by statement it will execute. Finally whatever the output is there, it will give the results. So main difference between the Hive and Pig is, so Hive is a data warehousing tool. We will write the SQL queries on it. So if you want to write the SQL kind of layer on the for analyzing the data, we'll go for the Hive. Pig, if we want to analyze the data by using kind of scripting kind of thing, we'll go for the Pig. So in Hive, we will have the tables and the meta store and everything we have. But Pig, we don't have that kind of thing. Simply we'll write the what are the things we need to analyze. We will write the different statement. Simply we will execute. So we will have the input and we will analyze the data. Finally, if you want to store output to again HDFS, simply we will store into HDFS. So in Pig we don't have the meta store kind of thing. So for the each statement, data it will store temporarily, and then once the program is complete, once the script is completed, then it will be all the data related to that one. We won't have any data, and we don't have any information about that Pig statements also we don't have. So we will see how the commands will be there, how the flow will be there. We will see in next slides. So coming to this thing, general thing is Pig is a high level language. So internally it will be depend on the MapReduce program. So whatever the Hive script or Hive commands we executed, internally it will convert as a MapReduce jobs. So used to analyze the large data sets and used to create MapReduce jobs. So we can easily create the MapReduce jobs. So abstracts defining of the jobs and use Pig Latin to define the jobs. So Pig Latin is a kind of language. So Pig tool itself, we will have the Pig Latin. So whatever the commands, whatever the keywords we are talking in the Pig, so all it will be come under as a Pig Latin. So those commands we will call it as a Pig Latin command. So it will be part of the Pig tool only, this Pig Latin command. So how we can run the Pig in different ways. One is grunt. So grunt is nothing but if you type the Pig interactive shell. So once if you go to terminal and if you type the Pig, automatically if you go to the one prompt, that prompt is called a grunt. So that name is grunt. Previously in Hive, if you type the Hive, we will once we enter into the Hive, so we will get the Hive greater than symbol. So like that here, if you enter the Pig, so we will go to the grunt cell. So whatever the commands if you want to type in terminal, we will type in that grunt terminal, grunt prompt. We need to type all the Pig commands. We will see that one. And we can also, another way is we can write all the commands, all the statements, Pig statements in the one file. We'll call it as a Pig script. So we can write all the Pig Latin commands in the script file and we can run it. So another way is we can run the Pig commands in the another language. We can run from the Java and we can run from the other language also. We can run it. We can run Pig in the two modes: local mode and Hadoop mode. Local mode, nothing but a single machine, or we won't interact with HDFS. Hadoop run on a Hadoop or MapReduce cluster is the Hadoop mode. So if you want to run the Hadoop mode, simply if you type the Pig, we can access in the Hadoop mode. If you want to run it in local mode, we need to type the Pig space -x space local. We will see that one later. So these are the two modes. So in the once submit the script, creates the MapReduce code automatically. So this is how the different commands will be there: load, filter, join, group by, for each, so order, dump. So we will have the different commands. So this is the SQL query, sample Hive query. So corresponding to this query, we will write like this. We will write the Pig Latin statements. So first we load the data. So whatever the input path is there, we will specify, and what are the fields are there, we will specify. Then if you want to filter by using any filter is like a where condition. Here if you check it, filter is like a where condition. So join is like a join, and group by is called a group by, like having, order by, limit also will be there. So like this we'll have the different commands. So whatever the how we are going to analyze the data, so we'll write the different steps, and we can execute one by one, or if you write the pig script, we can copy to pig script, and we can execute the pig script at a time. Okay, these are the basic idea. So what is pig and pig Latin, how the statements will be there. So we'll go through how we can install the pig. Before going to that one, so we'll see some example. So generally for pig, we will pass this as the input data. This is comma separated data. So while loading, how we can load means, so this is the statement load my file. This is the input path, and using pig store. So this is here in pig we have the this one. If you want to provide the delimiter, we need to use the some storage like pig storage. We'll have the different storage. We will see what are the things. So by default, it will be if you didn't specify any storage value, then it will be space. So here we are providing the data is the comma separated. So while loading data, pig storage, and we need to specify what are the delimiter is there. We need to specify, and as we need to provide the field like field name and data type, field name, data type, like this we need to provide. So once we load the data, so each statement will call it as a relation. So here this variable a will call it as a relation in the pig. So we can perform the operations, and once we load the data into this relation, so we can perform the whatever the operations we can perform on that one. So here if we observe, we can perform the operations on particular previous relation. So here for each means it will interact with the each element and generate group comma average g a dot salary. So here we are performing average, maximum, minimum, sum. So these are all the predefined or built-in functions in the pig. So like this, once we executed this relation, so finally we'll get the output like this. We can execute the each statement individually, or we can run the full flow, and we can finally we can, if we want, we can we can print in the console, or if you want to store the data, we can store into particular HDFS output. We can HDFS we can store it. I got one question from the Jay. So the result set are stored in variable in pig. Yes, yes. This variable we will call it as a relation in pig. So whatever the each operation, each statement output will store into relation. So this relation we will use in the next next statements we will use. So once we have the load relation, so load on this relation, we can perform the different operations, group by, unfilter, join. So we can perform the different operations on this relation. So if you want to download the pig, so you can directly go to the official site of the pig. So pig.apache.org. So you can go to the downloads page. So here we can go through. So you can click on any version. So you can download the version pig 12 or pig 13. So you can download the pig, and once all the things either Hadoop or Hive pig, so we'll have the this tar file. So we need to extract it. So once we extract, we will get the bin folder, conf folder, lib folder. So con folder only we need to whatever the corresponding changes we need to do, and we need to set the corresponding path, Hadoop path, and the pig path. So we need to set the variables. So these are the things. So we need to download the pig. So any of the version. So in our VM we have the 10 version. So we can we need to, if you want to access globally like pig, wherever we can type the pig. So in that cases we need to set the following paths. These are the paths we need to set in the bash rc file. Then we can directly use the pig from the any directory we can access. So these are the paths: pig underscore home class path, and these are the things we need to set in the thing. So already in our VM we already downloaded the pig. So we can we already set all these paths in the bash rc file. We can directly use the pig file. So before going to that one, we need to change the corresponding whatever the configuration is there. We need to check the pig configuration file, and we need to change the whatever the parameters we want to change. We need to change. This hive or pig we don't need to install in the all the nodes. So we can install in only one node. So simply we need to connect to that node, and we can write the either hive queries or pig scripts we can execute. So we can install any either in job node mission or job tracker mission, sorry, name node mission or job tracker mission, or any other mission also we can, if you want, we can install. Only single mission only we need to install this, either pig or hive. If you want to start grunt cell, simply we need to run the pig. So these are the previous what we discussed. High level platform for mapped disk program, simple syntax, use pig Latin language. So no shared metadata is required as in the hive. Here we don't need any meta store in the pig. So in pig terminology we have the different type of data types. These are the tuple, bags, and relation. So we'll go through that one. So these are the different data types: tuple, bag, and map. Tuple means is nothing but these three are the different data types in the pig. So tuple means order set of collections. So basically we'll have the like this. We'll have the data. We'll have the data by the comma separated. So bag is the unordered collection of tuples. So we'll have the, this is called as a bag. So we'll have the unordered collection of the tuple. So first tuple will have the maybe different fields. Here we'll have the order means maybe no need to, it will be in one order. So we'll have the different orders kind of thing. So this is the bag, unordered collection of tuples. Map is the collection of key value pairs. So like this we'll have the key and value, key value. So these are separated by the hash. So like this we'll have the different data types. So basically each output of the each statement will be the bag. So we'll have the output, we'll get the output like this, we will get the output. So here if you observe, this is the bag. So this is one tuple, this is another tuple. So each output of the relation, so each output of the statement, so we will get the output like this. So this is, we'll call it as a bag. Bag is a collection of the order elements. So each thing we will call it as a tuple. So what is relation? Generally the output of the operator is stored in a relation. So this is the what we are called as a variable, we will call it as a relation. So we will have the different keywords for loading the data. So for that, if we want to specify the delimiter, we will use the by using pig store. We will separate the data. Tab is the default delimiter in the pig. So if you simply provide the pig store, so that is the tab is the default delimiter. So if we want to, we can provide the other delimiter like comma, space, or any other delimiter. If you want to, we can specify. This is how we can write the load thing. So we'll see later. We'll practice few more statements, then we'll get more idea. So like we'll have the filter based on like where condition, we can perform any filter operations if you want, we can perform. Like group by operations we can perform. So grouping, how we will write the group by in the Hive. So like that we'll use the group. We can group the data by using any field. We can group. Join, if we want to join two relations, relations, we can join by using the particular field. We can join. We'll have the different joins, left outer, full outer, right outer. We'll have the different joins will be there. So if you want to access each element in the this particular relation, we can go for the for each. So like this, we will have the different statements. We will see one by one, describe, explain, illustrate. In Pig, like a Hive, we have the UDFs also in Pig, user-defined functions in the Pig. So how we will do in a Hive? Same way, we need to write the Java class. So we need to create the jar file, and we need to run. I think we need to run two statements in the Pig. So how we can load the jar and how we can map that class to the function. How we need to map. We need to do. We need to run that statement. We'll see next slides. We will see this more details about the user-defined function. This is the how we can write the different statements: load, filter, group, for each, order, and store. Finally, if you want to store, we need to use the store. Simply, if you want to display on the console, we need to write the dump keyword. We will see that one. And whatever the full these statements, we can write into one file, and we can give the extension .pig, and we can save it like this name, script underscore name .pig. So this script we can run by using the pig space, and that script file we can run it. So if you want to run in the inside the pig, you can run like a run space script name .pig, like this we need to execute. So if you want, we can execute. If you want, we can execute from Java also. We can execute. So in our VM, wherever we install the pig, so we need to go to that path. So user local pig. So once we downloaded the file and we extracted, we will get the different files like bin, con, different files we will get. So we can go to the con folder first. We need to go for the con folder, and we can see what are the files. So here we have the configuration file is pig.properties. So in this file we need to change the whatever the things we needed, we need to change. So here I think by default in our VM we will have the localhost. I have changed to master. So before running this one, we need to change to master. I think only this change only needed. We don't need the other changes. Only we need to change the that name node path, name node IP, name node host name node IP, and the job tracker IP only we need to change. So once if you change, so directly we can use the pig. You can use it from any folder. We can run the pig. So once you started this pig command, so internally if you observe, so here we'll go to the grunt prompt. So we'll go to the grunt cell. So here we can write the whatever things we are discussing. So we can write the statements one by one and we can execute it. We'll see one example how we can do the word count in pig. We will see. So here Amazon book, you can go through this one. If you type the pig, so we'll go to the grunt shell. So once if you are in grunt shell, we can write the what are the things. If you want, we can write it. You can perform all the file system operations from the grunt shell as well. Also, we can perform. So we'll see. I think whatever the Hadoop things, I think we can perform it. So if you observe, so these are the what are the files we have in the this directory, users Reno directory. So we can perform the Hadoop commands directly from grunt shell also can perform. So we'll see how we can write the word count problem using pig. We'll see that one. So I think already we have the data Shakespeare data. We already have the data in the Shakespeare data in the users Reno Shakespeare. So simply, before going to perform any operations in the pig, so we need to load the data into HDFS. So like Hive, we don't have option to loading data from the local. So in pig, we can if you want to perform the operations, we need to load to data will be compulsory. Data will be in the HDFS. So for that, we loaded the data into HDFS. Then we'll see one by one. So first we need to load the data. So here we don't want any delimiter. So y means each line will treat as a one field. So that's why we don't want to specify. We don't want to specify any delimiter here. So simply I'm loading whatever the data I'm going to load. So here in of Shakespeare I'm giving this path user screen. So this is my Hadoop path. So when the statements will executed to MapReduce, I will tell you. So simply if you write this statement, it won't execute at the MapReduce job. Whenever you executed dump or store a command, then only it will execute as a MapReduce job. So first we will write few commands, then we will run as a dump. So here we will see here I am going to first when it will call the MapReduce program, we will see. Before going to that one, I am going instead of printing all the data, I am going to limit data limit a 10. Then I am going to call the dump command. So dump instead of a, I will call the some other relation. I will call it dump limited data. So I'm going to print this. So whenever we execute a dump, then only it will convert as a MapReduce job. So we'll go through job tracker. So if you observe this one, it is converted as a MapReduce job. So what is dump command means? It will by using dump command, we will So we can display the data in the console. So if you want to store the data to the HDFS, we use the store command. So whenever we are executing dump or store, then only the MapReduce program will initiate, and whatever the statements or whatever the relations we given to the pig, this grunt cell, so automatically it will execute all the statements one by one. So here if you observe, so whatever the output is there, so that output will get as a this one. So this one we will call it tuple. I think previously we saw this one. So this is the tuple. So each line output will get as a tuple. So here we have only one field in the tuple. So we have the some previous other tools will have the empty data. So that's why it is showing as a empty. So this is how we can submit the pig statements to the as a MapReduce job. So next we will go through the other statement. So now we loaded the data. Now I'm going to split the data as a words. We will run all the statements, then we will check it. So for each line we need to specify the semicolon. So here what I'm going to do means, so whatever the data is there input this relation A, so I'm going to tokenize. If you want to get the first element like this, we need to access. We have only one element, so that element I'm getting by using $0. So if you want to get the second element, we need to give the $1, or if you specify any name for the particular field, we can call the name directly. So next example we will see that one. So here what I'm going to do means, so each line I'm going to split by using the as a word. I'm going to split the data. So then we will go for this one. After tokenizing, I'm going to split by using this one. Or next I'm going to group by. Like this we can write the different statements. Finally I'm going to count word comma. I'm going to print word comma count. Count I'm going to print. So simply final thing we can call it as a dump E. So whatever the operations we specified till now, so all the operations, if you call it as a dump E, then it will get the thing. So before going to that one, instead of calling dump E means we'll get the lot of words. Before going to that one, I'm going to limit the data. So here also I'm going to call the limited data equal to limit E. I'm going to call 30 or 50 we'll call it. Limited data. So once we submitted, all these things will executed. We'll go through job tracker and we'll see. So finally, whatever the word count we are doing. So previously we read the 100 of lines. So simply here we can write it as a 4 or 5 lines. We'll see that one we will write as a next to this example we will write as a script file, and we will see that one also. Here if you observe, so whatever the we are executed the relations, so here we can see it. So whatever the relations it is executing as a MapReduce jobs, we executed at the relation A, relation B, relation C, D, and final relation is limited data. So all these relations, whatever the relations we are running as a MapReduce job, we can see from the job tracker. So if you click on this one, so here we'll have the whatever the we have the lot of details. So here we'll have the like this we'll have the whatever the relations are there, we will see the relations A, B, C, D limited. So we'll see whether it is executed or not. I think it is completed. So if you observe this one, so we'll get the data like this. So we'll get the each word, we'll get the different words and count. So like this we can write the pig scripts, pig commands we can execute. So instead of writing the each command, so directly we can write the all the statements in one file and we can execute the pig scripts. So in our VM we have the pig scripts in the home training pig script. So here we'll have the different pig scripts. So here we can see the first we'll go through the word count. So this is the what are the steps we did. These are the steps. So instead of writing the lot of code for the word count, simply we will run the these 5 statements. First we load the data. So then we will we'll get the each first element as a word. Then that each line we are splitting as a by using this regex we will split. Then we are grouping the words. Then we are doing the group comma count operations. So then we will get the each word comma count of the words we'll get. So like this simply we can write in by using these 4 or 5 statements we can achieve the word count program. So that is the why we are moving to MapReduce to this pig. So simply we can write the statement, so we can execute the what are the things. So what are the steps we need for the processing the data? So we'll specify. So that's why only pig will call it as a data flow language. So like this we can execute the okay. This is the introduction about the pig and how we can write the pig commands and how we can submit to the this as a, how we can run as a MapReduce job, how we can see in the job tracker. So this is how we can do, how we can run the pig script. So these are the details. So we just we will see how we can run the pig script. So then we can go through the other examples. Okay, I'm going to edit this pig script file. So here I changed the input path. Load, I'm giving this expire data as input, and output. Previously we in command in grunt cell we executed dump command. So simply instead of storing into HDFS, simply we print we applied the limit operations and the we displayed on the console that screen. So instead of that one, if we want to store the relation final relation data into HDFS path, so we can use the store E into the corresponding path. We can store into that HDFS path. So we'll try to run it pig space. This is the instead of going into pig instead of going into this grunt cell, directly we can execute like this pig space, whatever the pig script is there, we can run it. So this will automatically it will convert as a map ready job. Instead of executing the each statement, we can run as a pig script, we can run it. So final, whatever the operations, whatever the statements we are executing, final statement, it will be stored into the this whatever the path we are specifying, HDFS path, we will store into that. So I think job is completed. So once it is completed, we can check the wherever we are storing the output. We'll go through that out. This is the path we given in the pig script. So we go inside. So if you observe here, so the output folder will commit as a where how we will go, how we got the output folder in the MapReady. Same like we'll get the part-r. So if it is MapReady job, then it will we'll get as a part-r. If it is a only map only job, we'll get the output as a map-m. So like this, we will get the all the word count. So whatever we achieved in the MapReady, so same thing we can achieve through pig. By using less code only, we can achieve. So here pig means simply we'll have the different statements. We don't need to create the tables. We don't have the meta stuff. Simply whatever the operations we want to perform, we will write the different statements for each operation. So simply we will execute. So that's why only whatever the steps we needed for the executing the flow, data flow, we need to specify in the pig script. We will run it. So that's why pig we will call it as a data flow language. So like this, we'll have the different words and the different word count we'll get. So this is the example word count example. So like this, we can run the pig scripts. So tomorrow we'll go through the other examples like how we can do with the log files. We'll do it, and regular expressions also if you want. How we can do it. So we'll see that one. So we'll go through some wiki example and log examples. Tomorrow we'll go through that one. Okay. Thank you all. We'll continue tomorrow. We'll practice few more examples in pig.